Right. Thank you so much, Coco. Hi, everyone. My name is Marilise Barnard. I'm going to be your teacher this evening. If you were here on Tuesday, then you maybe met Miss Lee, Miss Franklin, and she started doing a bit of trigonometry. So I'm going to carry on with that and take you through some of the very basic knowledge that you need to do trigonometry. Because I know trigonometry is a challenging section, and it's also a very big section in your paper too. It's anything between 30 and 40 marks. So yeah, one has to be on top of the sort of foundations so that you can tackle some of the harder things you get to do in grade 12. So for today and the lessons coming, we are just going to revisit some of those basic ideas around trigonometry. So like Ms. Coco said, keep the chat open, please, only for questions and comments about the lesson so that we can easily pick up your questions. And she's going to be assisting me with that and the questions that you guys have, but also feel free to raise your hand if you want to ask a question at any point. We are going to try and get to your questions, although the class might get a little bit big, so then it is probably better to just put your question in the chat. Okay, so that's all from my side in terms of housekeeping. Also, just remember to keep your microphones off so that there is no noise in between that might be disturbing anyone. Yeah, just unmute when you want to speak. Okay, right. So that's welcome out the way, and let's get going with our trigonometry. So, trigonometry. What is trigonometry actually all about? And we are literally going to start at the very beginning and remind ourselves about the three basic trigonometric functions that we get. And remember, when we do trigonometry like this, we're always working in a 90-degree triangle. For now, there are other times when we will be working in non-90-degree triangles. But when we start off and we do this trigonometry that we're going to be doing today, we are always working in a 90-degree triangle. So that's the first thing we need to realize. 90-degree triangles is what we are looking at. When you're in a 90-degree triangle, we can name the sides. We can say that the side that's opposite or across from the 90-degree angle, we call that the hypotenuse side. If this is our angle and this symbol here is theta, it is just a Greek letter for an angle of which we do not know the value. It's just an unknown angle. Then this is theta, and across from it is the opposite side, and next to it is the adjacent side. So hypotenuse, opposite, and adjacent. And we can make the three trig ratios using those sides. For sine, we are going to use the opposite and the hypotenuse side. For cos, the adjacent and the hypotenuse side. And for tan, the opposite and the adjacent side. Okay, so maybe you've learned these three. Maybe you've learned it as SOH CAH TOA. That's one way of remembering it. But those are our three basic trig functions: sine, cos, and tan. Okay. Can I get a thumbs up? Is everyone with me? Please put a thumbs up in the chat if you're happy with what I've just said and this is something that you know. Wonderful. Please put it in the chat for me. Great. Awesome. So if you want to jot this down quickly, that's fine. You can do that because we are going to be referring back to this as we continue. So, SOH CAH TOA. Let's apply it and let's look at an actual triangle while we are are doing this. Okay, so in this triangle, what we've got here is, again, we're in a 90-degree triangle. It's indicated over here. And then we've got two angles. We've got angle beta in this corner over here and angle alpha in this corner over here. Okay, it is just custom to use these Greek letters when we do trigonometry. Okay, so you must just, there's basically three that get used a lot, and that is alpha, beta, and theta. Okay, so maybe jot those down because you will see them quite a lot when you do trigonometry. And sometimes we don't know what they mean because they are literally Greek letters. So if it looks like Greek to you, it's because it is Greek. So feel free to jot them down, and they are used for angles, symbols for angles. Okay, so let's start. And I want you, just where you're busy working now, there on your own, I want you to just quickly jot down for me what is in this triangle sine of alpha, cos of alpha, and tan of alpha. And when you are ready, please put your answers in the chat. As soon as you're ready, you can pop them into the chat for us. Sine of alpha, cos of alpha, and tan of alpha. Just those three. Let me see in the chat what your answers are. Okay, Munash is in first with 16/34 for sine alpha. Yep, 16/34. Okay, so I assume everyone's doing sine. That's right. Lovely, okay. Great stuff, thanks, Benita. And we've got tan, lovely, Tsepiso. Maite, well done, cause, right, okay, good stuff. So let's go. It looks like most of us have a good idea of this. So we can say sine of alpha is the opposite over the hypotenuse side. So if alpha's over here, the opposite side is 16. And the hypotenuse side is 34. And we can simplify that further to 8/17. Cos of alpha is the adjacent over hypotenuse side. So adjacent, we said, is next to, so that's 30 over the hypotenuse is 34, and we simplify that to 15/17. Good stuff. Great. And then lastly, tan of alpha is opposite over adjacent, TOA, opposite over adjacent, and that is 30/16. And that simplifies down to 8. Nope, sorry. 16/30, opposite. Opposite over adjacent, no, that's right. 16/30. Let me just fix that. Is 16/30, and that is 8/15. Okay, right, let's do the same for beta. Here we go, sine of beta. Pop your answers in the chat when you are ready. Is it a must to simplify? Yes, you please must simplify. Use your calculator if you are not good at fractions. Yeah, definitely recommended. Thanks, Ms. Kaka. I agree with you on that. Pop your answers in the chat. Let's see. Sine of beta. So beta is the purple angle over here. So it's opposite over hypotenuse, and that is 30 over 34, which we are going to simplify down to, let's see what that simplifies down to, 15 over 17. Okay, cos beta, 16 over 34. I agree with that as well. So that's adjacent over hypotenuse, 16 over 34. And please simplify down to 8 over 17. And then tan of beta is opposite over adjacent, and that gives me 30 over 16. So 30 divided by 16, and that gives us 15 over 8. Right, wonderful. Thanks, Trix. Let's carry on. Looks like we are all quite good with our 3 trig ratios. Now what I want you to do in question C is work out what alpha is. What is the actual value of alpha? And when you have that, I want you to also work out what the value of beta is. When you're ready, you can pop that into the chat as well. Is there anyone who wants to put their hand up and give us the answer? Tell us how you get it. You can just raise your hand and unmute yourself.
We've got Monashe with his hand up. You can unmute.
Great.
Monashe.
Monashe, let us hear.
Afternoon, everybody. Hope everyone
Hello.
is doing well. With this question, I'm doing sine, or we're calculating alpha. So I'm using sine alpha, which we do know is equals to 16 over 34, or when you simplify it, it's equal to 8 over 17. So what you do is that you say sine alpha equals to 16 over 34. So now we want to find alpha. So we take the sine to the other side. So we say alpha equals to arc sine 16 over 34, which would give us a value of 28.07 degrees.
Wonderful. And that you do on your calculator. Okay. To find the angle, we're going to go, we can use either one of these. There's 3 options for us to use to work out alpha. And Monashe used sine alpha. So we can, I'm going to go with that. So we say on the calculator, shift sine 8 over 17. And that gives you 28.07. You can do the other ones as well. You can do shift cos, but then you have to say 15 divided by 17 on your calculator, and you'll get the same answer. And if you do shift tan on your calculator and say 16 over 30 or 8 over 15, you'll get that same answer. Wonderful. Right, Bonnie, what have you got to say? Let's hear.
Sorry, ma'am. I just wanted to understand. I didn't quite get how you got 28.07 degrees for alpha.
Okay, you've got your calculator with you.
Yes.
Okay, so find on your calculator, you press shift. I'm going to write down the keys here. Shift. And if you want to use sine to work this out, which is what I did, you press the sine button, shift sine, and then you punch in 8 as a fraction divided by 17 and equals. And that should give you 28.
Oh,
was asked.
okay. Okay, thank you, ma'am.
Now, I'm glad you asked because it's super important that you know how your calculator works. Okay, right. Who is going to volunteer for us? Beta. You can pop it in the chat as well. Now we've got two options. Well, we've got many options to work out beta.
I think Aisha wants to give us the answer for this one.
Asha, let's hear.
Okay, so what you do is do reverse tan, and then you put 15/8 in brackets, and then get your answer, which is 61.93 degrees.
Okay, wonderful. So you use tan on your calculator, going through these same steps with the keys. So shift tan 15/8 equals, and then you get 61.93. The person here that says his name is King Zooks, I think, yeah, that's correct, Miss. Oh, is it Sukanya? Check that your calculator is in degrees. That's very, very important. I think while we're on the topic of the calculator, let's quickly go there. You've got to make sure that your calculator is in degree mode, and that you press the shift button before you press your trig button, your trig function button. Okay, so degree mode and shift trig function button. Keith, we can use the cosine rule, but cosine rules are really for non-90 degree triangles. Here we've got a triangle that is 90 degrees, so we just stick to using SOH CAH TOA. Yes, I agree, Ms. Coco. That is exactly what I would recommend as well. Okay, right, let's move on. Okay, Dibutsana, you just need to, I think, round. If you're getting 61.92, I think it's just a rounding issue. Okay, can you see it? If it's not in degree mode, Ms. Coco, can you maybe just assist there how to change it to degree mode? It's just a simple reset, I think.
Sure.
Rightio, let's practice some more. Here's another triangle for you to do, and pop your answers in the chat. You guys are doing absolutely amazing this evening. Very well done, and keep going. So as soon as you're ready for question 2 with our triangle over here, please put your answers in the chat. Oh, Tandalwetu, yes, definitely. You can use the sum of triangle and minus the degrees. That's why I said we had many options to calculate beta, and that was definitely one of them. Well done. Right, answers are coming in fast and furiously. Whoops. I think I just wiped our whole lesson. No, just joking. I did wipe the questions though, somehow. Or they, oh, there they are. Something weird happening with my display here. Skaka, can you see these questions?
Yes, I can, but we're seeing half the triangle at the moment. So maybe if we can move up a bit.
Okay, let
There
me
we go.
move. Oh, okay, funny enough, this moved, this disappeared. It's always a little disconcerting when stuff just disappears.
Yeah.
Okay, I'm going to move the questions to over here.
There we go.
Okay, that's better. Okay, right. Let me catch up with everyone. So cos theta is adjacent over hypotenuse. So I agree, that's 15 over 17. As simple as it is, so we don't need to do any further work. Sine theta is opposite over hypotenuse. So opposite is 8 over 17 is 8 divided by 17. And tan theta is, Watobe says it's 8 over 15. Let's check. Opposite over adjacent, yes. Great stuff. And now we've got our angle, and we've got 3 different ways that we can work out the angle. We should all arrive at the same place though. We're getting theta, by the looks of it, it's 28,07. Let's check. So shift cos 15 over 17 is 28,07. Wonderful. Right, tricks. So that was our warm-up for the day. We are going to start going a little bit faster, or run a little bit more. You know, like when you play sport and you run and stuff, you first warm up. So we've just completed that step. So let me go find my other page. Here we go. Right. Okay, so what I want you to do now, here we've got, again, 90-degree triangle, and now we are going to solve for A and for B, the 2 sides, A and B. Let's see, what are we going to do here? So what we've got, and when you have a triangle like this where you have to find sides, okay, we don't have enough. Don't know if you've noticed here, but we don't have enough information to do Pythagoras. And that's exactly why mathematicians invented trigonometry, because Pythagoras only really works with distances. It doesn't work with angles. So we can use trigonometry to do that for us. Okay, so if I want to solve for A, so this is my opposite. Sorry. We are going to work with our angle 47. That's the one that's given. And the side opposite from 47 is 30. This is our hypotenuse side, and this is the adjacent side. I'm just going to call it adjacent so that we don't get confused with the 2 A's. So when we are solving a triangle, yes, you can do sine rule. But again, my recommendation is very much that when you're in a 90-degree triangle, it's much, much simpler to just use normal trigonometry, sine, cos, and tan. Because if you're using the sine rule, remember, you need 2 angles. So now you have to work out an angle, and you have to set it up with the sine rule. The sine rule is a lot more work, okay? Like I said, it's fine. You can do it that way. But because you're pressed for time in an exam, we always choose the most efficient way to do things. Okay, so we're going to make a trig ratio with the angle that we have and the side that we have and the side that we want. We want side A, and the side that we have is 30. So that's the opposite and the hypotenuse. So that is sine. Sine of 47 is 30. Divided by A. Okay, please put a thumbs up in the chat if you're happy with what I just said and you follow. Okay, Loretta, I haven't shouted for answers yet. Don't put answers down yet. I'll tell you when to put answers down, please. Okay, got some thumbs up. Good stuff.
I've got Cassandra saying she doesn't quite understand how we got here.
Okay, so I think there's a few of us that need just to hear it again. Okay, so we have to solve for side A and side B. We're going to start with side A. Side A is relative to this angle here, angle 47. It is the hypotenuse side. The side across from it is the opposite side, and this is going to be its adjacent side. So I take the side that is given, that I have a value for, that's 30, and the side that I don't have a value for, which is A, and I put those together in a trig ratio. And I see here that it's the opposite and the hypotenuse side. So that must be sine of 47, and that is 30 over A. So sine of 47 is 30 over A. Now we have to solve for the A, okay? And to solve for the A, we are going to cross multiply. We're going to cross multiply the A with the sine 47 and the one with the 30. And because we need to get A by itself, we're going to divide by sine 47. Remember, sine 47 is a number. So that's why we divide by it, to get our A by itself, just like a normal equation. Right, so 30 divided by sine 47. I get 41,02. Yeah, 41,02. Thanks, Solomon. I see you got that. Let's see if we can now go on, everyone, to do B. Solve for B. I'm going to take this away. No, I'm going to leave it. I'm going to take this away. Okay, and now I want you to solve for side B. Kulani, while everyone is working, what's on your mind?
Ma'am, it says correct 1 decimal place, so isn't it 41?
Oh, sorry. Yeah, you're right. Thank you. Let me correct that. Okay, awesome. Okay, I've got some answers coming in for B already. Okay, I'm going to give it 1 more minute. I want everyone to try. Okay, right, remember we're rounding to 1 decimal place. So if we have to make a ratio to solve for B, we use the side that's given, the opposite side, and the side that we are solving for, that's the adjacent side. So opposite and adjacent, that is tan. So tan of 47 degrees is 30 opposite over adjacent, TOA over B. Okay, so we have to do our cross multiplication again so that we can solve for B. I like to just put that over 1 because then I'm looking at the same thing, fractions. So B is tan of 47, and that is 30. And now we are going to divide by tan 47 on both sides. And then B is, on your calculator, 30 divided by tan of 47. Okay, I get 29. Let's think carefully about our rounding here. 29,9754, da 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 da. If we round to 1 decimal place, we have to round up the 9. Because it's a 9, it's going to go, sorry, I get 27, not 29. Let me just fix that. So that's going to go up to 28. Okay, so with the rounding, you should get 28. Yes, can you see there?
Ma'am,
on my side, I keep on getting like 28 degrees. Using
Yeah,
30 over 10, 47 degrees.
Yes, 28 is right. That's the correct answer.
Oh, okay.
Okay, good stuff. Right,
I heard you say 29. I heard you saying 29. So
oh yes, I did. And then I corrected it to 27. You're right.
oh, okay, thank you.
Okay, right. So here's another one. Now we are doing the other. Is it fine for you to use Pythagoras? Sorry, I just want to answer this question. Yes, it is fine, but because you're now in grade 12 and Pythagoras is really something that you did learn in grade 8 and grade 9, I really want you to practice your trig. Okay, right. Here we have to find the angle. Okay, give this one a go. We're going to do 2 minutes and then we're going to look at it. Finding theta. Lebogang, I'm reading your comment here as well. That's fine. How did you, I'm not sure how you used cos. Oh, you used cos because you just used the side from earlier on. That's fine too, yeah. Okay, so here's our angle. Roger says 59.7, but not sure. Not sure. Yeah, we're doing again correct to 1 decimal place, right? Yeah, 2 minutes almost up for this one. Okay, so we are going to use the opposite. Here's our hypotenuse. Here's our adjacent. So we are going to make a ratio with the opposite and the adjacent because those are the two sides that were given. So tan of theta is opposite over adjacent, 24. So because we're solving for an angle, we're going to do what we did earlier in the lesson, shift tan 41 over 24. And that gives me theta is 59.7 degrees. Great stuff. How's everyone feeling? Put an emoji in the chat so that I can see how you're doing. Okay, thank you. Great. Good, Nolwasi. Wonderful. Sure, Miss Coco, we are 105 in this meeting this evening. All coming together to learn maths. How nice is that?
Yeah.
Yes, awesome. Thumbs up for sure. Great. Right, guys, so I'm just going to skip a little bit ahead to this one here. Wonderful. Right, so here we've got something a little bit more complex. So let's see. We have to find, we are given, first of all, this triangle. It's got one angle that's given, that's 30 degrees. BC is 22. We have to find for question A what TC is. And then we have to find the length of AT. And then lastly, the angle BAT. BAT. Right. So let's all start first by finding the length of TC. I think we can all manage that. It's very similar to what we just did. So we've got our 30 degrees here. And for now, we are just going to work in, and I'm going to highlight it for you. And remember, nothing stops you from highlighting things on your sketches so that you can see them more clearly. Maybe that's not the best color to do it in. Let me see. I'm going to use, let's just use blue. Feeling primary colors this evening. Okay, so the length of TC. We're just going to look in this 90-degree triangle to find what TC is. So if we look at 30, again, we're going to work relative to 30 degrees. This is our opposite side. This is our adjacent side. And this is our hypotenuse side. So because we are looking for TC, we are going to use the side that's given, the 20, and the side that's not given, CT, the one we are solving for, in a trig ratio. So that ends up being cos. Cos of 30 degrees is CT over 20. Okay, we do our cross multiplication thing here. Very important that you understand this bit about the cross multiplication because you use that a lot in trigonometry. Also when you do sine rule later on. So cos of 30 times 20 gives me, is there a rounding instruction here? No. So we can round to 2 decimal places. I get CT is 17,32 centimeters. Good. Great. I think everyone else is getting that too. That's what I'm seeing in the chat. Good. If you round to 1 place, that's fine, or 2 places. I think let's round to 2 places. Just going to add that there. Okay. Now, what is the length of AT? AT. Loretta, you keep saying your answer and then you say, I'm not sure. Okay, so AT, now we can do that in 2 ways. Okay, you guys can use Pythagoras because we've just solved for this side here. We said that's 17,32. But let's try and use trig, okay, so that we can practice our trigonometry. So AT is the opposite side. And the side we just found is the adjacent side, so we can do tan, or we can do opposite over hypotenuse. We can do sine. I like sine, so I'm going to do sine. Do you know what it is about sine? Okay, I see lots of people getting 10. Let's see if we can all get there. Over 20. So 20 times sine 30. Let me just label this question here. Yes, I also get 10. 10 centimeters. Well done. Awesome. And
as a matter of fact, Ms. Marlies, I think we should have known that we were going to get 10 because if we know our special angles, we should have known that sine of 30 degrees was going to give us a half. So
yes.
Some of you guys might have picked up on that before you even had to pick up your calculator.
Oh, wonderful. Because the special angles is actually the next thing we're going to do. So I thought I wouldn't put everyone under pressure with that. I thought
I'm sorry, I may have jumped the gun a little bit.
No, that's fine. I think some people did pick up on that, so that's great. Okay, so what's the last one? The angle BAT. Angle BAT, right. So how are we going to find BAT, this angle over here? Right, let's hear. Ordain.
Ma'am, for BAT, now we can first find the side AB.
We can first find
using
side
the
AB.
cosine rule.
Okay.
Yeah, we can use the cosine rule, and then we now
Okay.
use and then angle ATB is also 90 degrees.
Yes, that's
and
90.
then we can now use SOH CAH TOA to look for the angle A.
Okay. All right. So we can work out what BT is. because we know that full side is 22. So we can subtract from it 17.32, which is the length of CT. So that gives us, I'm just going to make a little arrow here, 4,68. And we also found this one here, AT, right? That was 10. I'm just going to do that. And that's enough information to make a trig ratio with. If we're looking for this angle here, the opposite, this is the opposite side, this is the hypotenuse side, this is the adjacent side. So we are again going to use tan. Right, so tan of angle BAT is opposite 4,68 over adjacent TOA 10. And we go back to our calculator and say shift tan 4.68 divided by 10. That will give us BAT. Who's got an answer? Siamo, Tepiso. That gives me 25,08. Okay, I run that again. So we can work out, we are now working in this smaller triangle. I'm going to highlight that triangle in a different color so we can see better. So we are now working in this adjacent triangle. And we have already figured out in question B what AT is. AT is 10. And the hypotenuse side, we don't know. We don't need to know it. And we can work out, because we know that CB, like it's given here, CB is 22. And we already worked out that CT is 17.32. That means that TB is 4,68. We're just going to go 22 minus 17.32 is going to give me BT, and that is 4,68. This is the angle, this one that I've highlighted here in red, and now I'm scratching in green. This is the angle we're looking for, BAT. BAT. So across from it is the side that we just found, so that's opposite. And next to it is the other side that we have just found, which is the adjacent side. So it's opposite and adjacent. So we use tan. Okay, so I just explained about the 4.68. So I hope that is now making sense. Why do we need to know the length of BT, Norwazi? Because we are trying to find a side and another side so that we can make a trig ratio so that we can calculate what the angle is. Just give me a thumbs up if you understand that. Okay, that's why we needed that. Okay, cool. Thanks, Norwazi. Right. Okay, I'm going to give a few minutes for questions. We do have a quiz today, so I'm going to let you go soon so that you can go and complete your quiz. In our next lesson, we are going to carry on and look at those special angles. And then we're going to go on to tackle reduction formula, which is the grade 11 stuff and also very important for grade 12. Okay, so everything we're doing. Ma'am, are we only calculating angle A in triangle ABT? Yes, that's the only thing the question's asking for. Question C says the angle BAT. Okay.
I'll answer Geketso in the chat, ma'am. I think you can continue.
Okay, thanks, Ms. Kako. Okay, if that's all for today, any other questions? Sine B, the very first one, sine beta. Okay, right. So, Ms. Coco, will you also answer Michelle when
Will do.
you get a chance?
Will do.
Okay, so Riyadh, we knew that BT, because it's adjacent to the already existing 90-degree angle, and because it's on a straight line, that's why it is also 90 degrees. This one here. That one was given, and because it's on a straight line, we can say the adjacent angle is also 90, because together they must make 180. Okay. Right. Yes, can you see them?
Ma'am, we said that T, then we have a right angle like at ATB, ma'am. Do we need to put a reason for that, or we just write it and?
Not when you're doing trigonometry like this, you don't have to.
Yeah. Oh,
Yeah.
okay. Thank you, ma'am.
If you were doing geometry, you have to put reasons. Okay, right, guys, there's lots of questions about the quiz, so let me explain. When you are done here, Ms. Coco, do we have the link for the quiz?
I do. I'm about to pop it in the chat right now.
So Ms. Coco is going to pop the link to the quiz into the chat, and then you just click on that and you'll get taken to the page where the quiz is. You're going to start your quiz, complete it. There is a time limit on it. And as soon as you're done, yes, you'll get your result and you'll get the answer as soon as you are done. But you have to follow the link that Ms. Coco just put into the chat. And yes, I'm going to leave you to it. You can go now and do your quiz. Thank you so much, grade 12s. It was lovely teaching you this evening. Well done for your homework. Okay. All right. Some people are very excited. Right. Okay. Thank you, everybody. Go off and do your quiz. Good luck. Don't stress about it too much. It's an easy quiz.
Thank you, ma'am, and thank you, Coco. Bye.
Thank you, everybody. We see you
Bye,
again next
guys.
Tuesday, hey? We see you Tuesday.
Yes.
Please complete your quiz.
We will, ma'am.
Okay.
Wonderful.
Bye, ma'am.
Bye,
Bye, everybody.
Bye.
Bye.
I will.
Ma'am,